So let's look at the following example. A person leaves his home and travels north for 25 kilometers. So let's symbolize that by vector 1. So here we have a person traveling upward along the y-axis. So our magnitude is 25 kilometers. So that's vector 1, v1. They then make a 60-degree turn right and travel for 50 more kilometers. So from this point, our person makes a 60-degree turn with respect to the x-axis and travels 50 more kilometers along this direction. Now we want to find what the resultant vector is, what the displacement is from our initial to our final position. So we're looking for this blue vector. So we want the magnitude of this vector as well as our direction. We want this angle between this vector and our x-axis. So the way we're going to solve this problem is by resolving our vectors into their x and y components, then adding up the x and y components using our formula and using another formula to find our angle, aka our direction of our vector. So let's begin with part A. Resolve both vectors, vector 1 and vector 2, into their components. So let's call vector 1 v1 and vector 2 v2. So let's begin with vector 1. So here we have the y-axis and the x-axis. Notice that our person is traveling strictly along our y-axis. V1 goes along our y-axis. That means since the person doesn't move left or right, our x component is 0. And since our person only moves upward along the y-axis, that means my vector v1, the magnitude and direction, is equal to the y component of that vector. So vy1 is equal to 25.0 kilometers. And Vx1 is equal to 0 kilometers. So let's go to our second vector. Let's take this vector and bring the initial point to our origin. Now we see that this entire magnitude, the length of it, is 25. So V2 is 25. And our direction is 60 degrees with respect to our x-axis. So if this is 60, this must be 30. So here we have our component along the y-axis and our component along the x-axis. So notice that we can use our trig functions to find the value of our vy2 and vx2. So we know what our hypotenuse is and we know what the angle is. So in order to find what our component along the y direction is, we simply use our cosine. Cosine is adjacent over hypotenuse. So that means we have y along the, or our vector along the y direction, a vector 2 is equal to negative of cosine of the angle multiplied by our magnitude of v2. It's negative because notice that our v component, or v along the y component along the y direction, goes downward. So we choose upward to be positive, downward to be negative. We choose right to be positive and left to be negative. So negative cosine of the angle 30 multiplied by 50, the magnitude of v2, and that equals negative 43.3 kilometers. So now let's find our component along our x direction. So now we're using sine, the sine function. Sine of the angle 30 is equal to our opposite divided by our hypotenuse. So we rearrange and we get the magnitude is equal to sine of the angle 30 multiplied by 50. Sine 30 is 0.5. So 0.5 multiplied by 50, we get 25.0 kilometers. So now we go to part B. Now we know the x component vectors and the y component vectors of both of these vectors. So our final x component vector is equal to the sum of our two components. So our component x for vector 1 and our component x for vector 2. So we said this was 0 and this was 25. So 0 plus 25 is 25 kilometers. Now, what about our component of the resultant vector along the y direction? So Vy1 plus Vy2, so Vy1 is 25 kilometers, and Vy2 is along, or is negative 43.3 kilometers. So 25.0 plus negative 43.3 gives us negative 18.3 kilometers. So now we know our x and y components of our final resultant vector. So we use the following formula, which we derived from our Pythagorean theorem. So the radical of this squared plus this squared. So we get 25 squared plus negative 18.3 squared. Take the radical of that and we get approximately 31.0 kilometers to 3 significant digits. So this is the magnitude of our resultant vector. What about our direction? So we can get our direction by using tangent. So tangent of this angle is equal to Vy divided by Vx. So the component along the y direction divided by the component along the x direction. So we use the things that we got from part B. So our Vx is 25 and our Vy is 18, or negative 18.3. So we get approximately negative 0.732. Now we have tangent theta is equal to this. So we want to find what the theta is. So we take the inverse of tan. So tan inverse of 0.732, this should be negative, and we get negative 36.2 degrees. So the negative simply means that we're below the x-axis. So our angle is this angle here going in the negative direction. So going counterclockwise is positive, going clockwise is negative. So this is our final angle. So the magnitude of our resultant vector is 31.0 kilometers, pointing in the direction 36.2 degrees below our x-axis.